Yo,
Anybody
what's up,
besides
Franco?
me?
Oh, yeah, yeah, I can hear now.
Or
Yep. Yeah, I heard Taylor, and what's it?
By the way, what else would
Yo,
work is like a concave like lens type of thing. But all right, Alan, take it away.
thank you, sir. Franco, are you there?
Hi.
Yo, so a couple of things that I wanted to ask you about, starting with your explanation that you gave earlier in the day about Airy's failure, where you said that you can't use velocity addition on waves, and you said that that Fresnel drag was invalid for some reason, but you didn't specify why. And in addition to that, there was there's just regular interferometry, so the Sagnac effect, which is best described with the classic equation that doesn't require any transformations. That's C plus or minus V for a wave. So the idea that you can't use wave velocity addition is false. So I'd like you to explain yourself. Because it seems like you're just arbitrarily flip-flopping, because last week, or a couple weeks ago, your guys' explanation, sorry to ramble on that, but I wanted to tie the relevance into last week. A couple weeks ago, your guys' explanation was that if you account for the velocity on the other end, meaning that if you do a mathematical transformation and assume Earth's horizontal velocity component and transform that into the incoming light frame, you guys said that that would predict no angle change. And you guys gave the example about a moving trash can and dropping a ball and having it drop in the center, and how if you account for the timing when you drop it, that's the equivalent of doing the velocity transformation. Now, so you were willing to say that it predicted no fringe in that using velocity addition, but now you're saying that it's invalid in the face of experimental evidence and measurement.
So, sorry. Can I answer?
Absolutely. The floor is yours.
Okay, so what I said is invalid is the velocity addition when you consider plane waves. When you consider plane waves, what you have to do when you move from one reference frame to another one that's moving with respect to the previous one is that you need to transform wave vectors. And this is for plane waves and phase velocity in plane waves. Now, this is exactly the same as using velocity addition, relativistically speaking, when the waves are in vacuum, when they are light waves in vacuum, the calculation is exactly the same, and the results are exactly the same, meaning transforming plane waves in vacuum and transforming velocities in vacuum is the same, as long as light is concerned in vacuum. When it comes to moving media, things are a little bit trickier, because it depends what you're considering. If you're considering just plane waves, which in my opinion is the case when you consider starlight. And by the way, I'm also trying to read Klinkevo's, or however that's pronounced, Klinkevo's paper or book. And he also, in his calculations, he also uses plane waves as a description of starlight, and explicitly says so. But if you use plane waves, then what you have to do is compute how the wave vector transforms. If, on the other hand, you use wave packets, for instance, because you want to describe photons, or if you want to describe light pulses or localized light signals, then you have to use, you can't use what's called phase velocity in a medium, but you have to use group velocity. And in that case, for group velocity, it's true that one uses velocity compositions, relativistic one. So it really depends what kind of light transmission you are using. It also has to be said that, as I showed in my calculations that I posted 2 weeks ago, that in the case of Fiesels experiments, meaning when the light is propagated in the same direction as the velocity of the medium, then the two things coincide again. And so using wave vector composition or wave vector transformation or velocity transformation is the same, gives the same result, which is the drag of the light by water. Concerning the formula used by predicted by Fresnel and mentioned by Jackson's first edition with the 1 - 1 over n squares or whatever, my comment on that was that it's not the prediction from exact prediction from velocity addition or wave vector transformation. I repeat that they give the same result in this case of parallel directions for velocity and propagation, and because it's only valid to first order. But of course, Fissel's measurement was the precision of the measurement was made it perfectly describable by the first order calculation. So this is about Fissel. Concerning instead the explanation of what happens with water telescopes. In case you use as Klinkerfues did, as I still think it can be done. You use you model your starlight propagation as a plane wave. You describe it as a plane wave coming to the telescope. Then the calculations I posted two weeks ago show that if you change frame, that is, if you compute what happens in a frame to light refraction in a frame where the refracting medium is stationary, and then move to a frame where the medium is moving with a certain velocity, which is parallel to the interface surface, then in that case, for plane wave refraction, you have that the Snell's law is conserved, which means it is obeyed in both frames, which is not true if the interface surface is inclined, has got a tilting angle. Still, but if you don't agree with this, meaning treating starlight as plane waves and computing their phase velocity, and you want to compute group velocity, meaning the velocity that a localized wave pulse would have, then you would have to use group velocity in water, and in that case, you would have to use, when you want to transform from one frame to another, you would have to use relativistic velocity addition. Still, the argument that the angle would be increased from 20 to 27 degrees is based on the assumption that, for instance, in the so-called sun frame, in the frame where the Earth is moving at 30 kilometers per second, starlight coming from Gamma Draconis and coming along the y-axis, for instance, in the sun's frame, will meet the moving telescope and will keep that direction, y direction, when entering water. And then when you transform to the Earth's frame, that would give, if you use relativistic transformation, would give two different angles, and indeed the angle would be 27 if you use relativistic velocity addition. The wrong part here is that it's not true that when the light enters a moving medium, the direction will be conserved. That is not true. It is true for plane waves, but I showed that. But for light pulses, meaning if you use velocity addition, then if you use group velocity, then no, it's not true, because you don't know it from first principles. We only know what happens to light when it crosses an interface between media, when the media are stationary. Then what you have to do is to go to that frame, compute in that frame what happens to light, and then move to a frame where water is moving. That's a mistake. You cannot, and that is independent. This argument is completely independent of what light, what you use when transforming from a frame to another. If you use relativistic velocity addition, or you use relativistic transformation of wave vectors, because in both cases, what you need to do in order to know what happens to light when it crosses the interface between two media is what you know from physics, from the physics of refraction, with the refraction index and so on, which and the velocity of light in water, which you know only in a frame where water is stationary. In order to see what happens in another frame, you have to transform to a frame where water is moving, and that is not, and that is what is done wrong when you assume what happens in the so-called sun's frame. From the point of view of relativistic physics, all frames. This is what I said even before starting reading all of this stuff by Airy and Glinkerfues and whatever. From a point of view of modern physics, or relativistic point of view, all frames are equal. All inertial frames are equivalent. So if you want to know what happens on Earth with a water-filled telescope, you just use the Earth's frame. In the Earth's frame, considered as inertial, you have light coming in at a certain angle in a telescope, and then it doesn't matter where that light comes from. The telescope, the interaction between light and water is not dependent on the origin of this light. So if light is coming at 20 arcsecond degree with respect to vertical to the telescope, it would be just refracted to 15 arcseconds in water, because that is Snell's law, and that is not dependent on where the light comes from and what is its origin. That is the point of view. The timing argument is flawed because the timing argument assumes that in a frame where the water is moving, light keeps going straight, which is not true in general.
All right, give me 1 second. I'm going to reconnect here because the audio started messing up at the end there, and then we'll continue. Give me 1 second, please.
I'll go ahead and post some of the tweets you guys were talking about. I've seen some of your tweets, Franco, so I'll post some of them so some of the audience can follow along as well, guys. Loud and clear.
Okay, so number one, starting off with treating the incoming starlight as a plane wave is not, I don't accept that, right? A plane wave doesn't even exist. It's an idealized conception of light propagation. Now, all light experiences attenuation, diffraction, and refraction. And when it interacts with particles, et cetera, as it's traveling through the cosmos and our atmosphere, et cetera, it's going to create spherical wavefronts. So it's not going to, that's not a valid analysis, number one. Number two, if a plane wave did exist such, it would be equivalent to Fresnel's experiment, and it would be just as valid. It's exactly what was measured for number one. And you were saying how in a moving media, you can't make the right prediction, et cetera. Well, if you, in Fresnel's experiment, if you take the water frame, right, you can predict the speed of light being measured plus or minus v with respect to the flow, and with respect to the lab frame. So you can absolutely make the correct prediction there using velocity addition for waves. Number two, the biggest issue, right, is the massive flip-flop that's gone on here. That's not to be lost, right? So the original argument was you can use velocity addition. Now you can't use velocity addition. And as you said earlier, if you try to use relativity theory, you're saying that you can make two different angle predictions via transformation, but then you said that all reference frames are equally valid. If all reference frames are equally valid, then they have to make the same prediction for the physical measurement. So that's not valid. That's an asymmetrical use of relativity theory. They all have to make the same prediction. And the classical, the relativistic velocity composition agrees with the classical up to 2/10 millionths of a degree. So there has to be an angle change of 27.5 arc seconds at the bare minimum. And you keep saying that like it only accounts for the first order, blah, 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 right? Well, the first order is the only order that matters. That's the order where the measurement was taken. That's where it's directly proportional. Like when you say that it only does it to the first order, that's exactly that's extremely important. That's not to be lost, right? Like interferometry is so precise because it's first order measurements that are directly proportional as the square or of the ratio of a square. So it's not like it can just be whatever. Now, secondly, or not secondly, but let's see, there was a couple other notes here I took throughout that. Wave packets. So you were talking about wave packets earlier and the distinction between like when it's traveling in its idealized quantized form through a vacuum and then it hits a medium and it becomes a wave. and that's you're talking about wave particle duality there, which I don't accept either. And you could substantiate that through a double slit experiment using water, where you would see the interference pattern caused by particles rather than waves, and that's never been substantiated. But in fact, you can actually use a fog machine to a classical double slit experiment and see that the diffraction pattern of a wave is present through all the slits. So it's never a particle at any time. So this idea that it's going to be propagating through a vacuum and then transforming into some uncalculatable, unusable thing is not a tenable position. Let's see. Inertial navigation system. So yeah, like I was saying earlier, you were talking about that it's only valid for the first order. They only use the classical equation in inertial navigation systems, bro. The Lorentz physics doesn't exist in a ring laser gyroscope. So we're talking about one of the most precise instruments made to measure motion, and it's so precise that the ionization of the gas in the chamber is causing a preferred direction based off of the electrodes of the device, like the alignment. And they have to offset that because of Fresnel drag is it's basically making the light get there a little faster, and that's interfering with the accuracy of the device. And they're using the first order equations for it. So it's just as valid. You can't say that it doesn't work magically. That's not a real explanation. You've completely flip-flopped. And I don't think I need to say anything else. Let me check my notes real quick. Oh, right. The starlight. Okay, yeah. The other issue here was that you were saying that the starlight comes in at an angle. It doesn't come in perpendicular, right? That's what we learned from Airy's failure. It already comes in at an angle. So when you add the water, it doesn't change. So the idea that it comes in directly perpendicular isn't a thing either. And the angle of refraction is accounted for, and you only need to account for that when you focus on the speed of light difference for the angle increase. So nothing that you put forward of an explanation, like half of what you said isn't even physically applicable because it's an idealized calculation of a wave, right? And the other half is just a flip-flop and misuse of your own mathematical symmetry. The floor is yours.
Dang, Alan.
I didn't follow everything you said here because there were many things. Again, going back to the 20 to 27 angle change. If you use that, how do you use that? You said you use you can derive that by starting from a zero angle with respect to the y-axis, and then transforming to a frame which is moving to the right, say, or to the left, along the x-axis, with a velocity which is 10 to the minus 4 the speed of light, which is 30 kilometers per second. If you do that, you come up with an angle of 20 arcsecond with respect to the vertical in vacuum, and with an angle of approximately 30 arcseconds in water. This is, if you suppose, then in the original frame you're transforming from light is going along the y direction, because otherwise you won't get these angles. This assumption is wrong if the water is moving in the first frame, the frame where you're starting from, because you don't know what happens to light entering a moving medium. In order to compute that, you need to go to the frame where the water is stationary, use refraction laws, and then transform back to the frame where water is moving. That's the only way, because otherwise you will have to solve Maxwell's equations and boundary conditions with a moving interface, which is not, and a moving medium, which is not easy at all. It's not something that one can do very straightforwardly. Absolutely. So the way of doing that is transforming to the frame where the water is stationary. This is independent of how you make the calculation of how things transform from one frame to another. There's no need to go to the frame where the water is moving in relativity. As far as wave packets and plane waves are concerned, the claim is it depends. The timing argument, that is, for instance, the videos that have been circulating about Airy's an aberration being viewed with a bullet coming down from the sky and crossing and having to be caught by a moving telescope. This is something that is modeling the light signal as a moving bullet, moving at the speed of light or at the speed of light in water. This description can only be accepted in case you have a very localized pulse. You may call it a photon, you may call it whatever. You may call it a very localized wave, light signal. I don't know. For instance, in a optic fiber or something like this. But in that case, when you want to see what happens when you transform between frames, then you're allowed to use velocity addition. Again, my previous claim was that velocity addition is not correct when you deal with plane waves. A localized signal is a sum of plane waves. Plane waves, it's true, are idealized mathematical concepts, but they're just a sine function or a straight line or a parabola. They're all mathematical abstractions, but they're used in Fourier analysis to describe, for instance, localized distributions. For instance, and a localized signal, pulse light signal is localized light signal pulse is described as a sum of plane waves. So, in order to see how this behaves, you need to know how a single plane wave behaves, and then you compute how the sum of plane waves behave. And if you do this for localized and on a certain very particular hypotheses, you compute what the velocity of a localized signal is, and this is the so-called group velocity, which is not frequency divided by wave number, but is the derivative of the frequencies with the frequency with respect to wave number, which is the same as phase velocity for isotropic non-dispersive mediums such as water. In case of moving water, then isotropy is lost because you have a particular we have a special direction, which is the direction of the velocity of water, and then you cannot. It's true that group velocity does not equal phase velocity unless the velocity is parallel to the water's velocity. In that case, the two are equal. But if not, they're not equal. So if you want to deal with the movement of localized pulses in moving water, you have to use group velocity, and that does transform according to velocity composition, relativistic one. The relativistic
Lost
one.
you, Franco.
Lost me.
You're good. Keep going.
You lost me. You lost what I'm saying, or you lost the audio?
No. Just if you could draw a conclusion, please.
Well, the conclusion, this was about the difference between group velocity and phase velocity. The conclusion is that independent of what you use, in order to determine what happens to light in moving water, the only way of doing it is, especially when light is crossing the border between the boundary between two media, is to compute what happens in the frame where the medium is stationary, because that we know how to do, and then move to a frame where the medium is moving. You cannot do the reverse. All the demonstrations of what is supposed to happen in a frame where the telescope is moving are flawed because they assume what happens to they incorrectly assume what is happening to the light as soon as it enters the moving telescope, which is not obvious at all. In order to do that, you have to move to switch frame and then go back. There's no way you can do it. You can do it directly. What I did in my previous in the slides that I showed 2 weeks ago was to do that computation for plane waves. It is true that if you do it for wave packets, so for a different model, you get a different thing when you go to the moving frame, but not when you are in the frame where water is stationary. In that frame, in both cases, you get that what is obeyed is Snell's law. So there's no contradiction. There's only a contradiction if you use two different models. If you want to know what happens to a light pulse or to a plane wave, they behave slightly different. They behave differently in the frame where the water is moving. But in the Earth's frame, there's no difference.
All right. Well, do you have a pen and paper, sir?
Yes, I do.
All right. As I'm speaking, please write down any points you feel are necessary to address. I don't ever want to hear you say, "Oh, you took too long. I didn't follow that." After the way you just put forward and what I had to write down to keep up with you, that was completely unrelated. So, with that mutual understanding, we're not going to complain about length of speech anymore. And we're going to address points directly and follow along when we're speaking. So, number one, you're assuming Earth's velocity in this whole situation to begin with, right? Now, on top of that, that's affirming the consequent for number one, right? You're saying, oh, it's different, it happens different, it's going to do this, it's going to do that. We know exactly what's going to happen because we've done Fresnel's experiment, right? And it's completely valid. In the first order, makes the correct prediction. You admitted earlier that the plane wave idealization doesn't matter and it doesn't exist, so why bring it up? And then you go on to try and talk about how the group velocities and all these things will be different, yet I'm giving you practical real-world examples of measurements where it's not different, and it's exactly described in the classical sense. You keep inventing conditions to give a different outcome because of the implication here. The starlight comes in, hits a medium, the angle increases. That's what relativity predicts. That's what the classic theory predicts. If the two didn't make the same agreement, then they would be wrong, because all you're doing in the classical prediction to make it relativistic is adding a gamma factor at the end, which is so small that it cancels out. It makes the agreement of the equation 2/10 millionths of a difference. So it's not even a real thing, right? Now, on top of that, let me scroll through here. Let's see.
Hey, hold on 1 second. I'm listening to the background, guys. My bad.
Additionally, what you're doing here, right? They're saying that there's stellar aberration in air, right? So if you're doing this horizontal velocity composition transformation to the incoming starlight, that would also have to apply when it's incoming in air, and there would be no aberration to begin with. So that's wrong. Now you keep getting. Oh wait, Am I coming through? Can you guys hear me okay?
Yeah, we can hear you, but we don't think you can hear Sacred.
All right, I can't hear you guys. 1 second. Let me rejoin.
While we get Alan back up, plus he's having so much issues. Franco, do you know what affirming the consequences?
Sorry?
Yeah, we can hear you, Alan. I don't think you can hear us. Can you hear us now?
Yep. Sorry about that.
Yeah, I was just asking Franco if he understood the term affirming the consequence.
Affirming the consequences.
Affirming the consequent. It's where you told him that his analysis was invalid because it's only valid in a frame where water's stationary. And if in a frame where water's actually moving, then you would have to do a more complicated equation. And so therefore, based on that, he's wrong. And he's saying you're taking the point of contention, which is the fact of whether the water is moving at all or not, and you're using that as evidence to affirm the point of contention, which is a logical fallacy known as affirming the consequent. All right, go ahead. Go ahead, Alan.
No, I'm not familiar with these things. I'm familiar with other type of reasoning, but no. So I don't know what you mean. I still stand by what I said, meaning
It's based on logic. Affirming the consequence, it means you're assuming Earth's motion without confirming it, right? Because the test of Earth's motion was the angle change when you add the water, right? So the fact that there was no change means that the Earth isn't moving, right? But the philosophy, the idea that the Earth is in motion was kept. So now we have to have all these weird answers that don't make any sense, that contradict physical measurements and reality. And that's where we're at now, right? Is like all this assumed velocity vector that you're trying to transform that would make aberration invalid in air, right? You're trying to have it both ways. And then you're doing asymmetrical transformations and you're saying that it predicts different angles for different things. That's not correct, dude. That's literal gobbledygook and a complete flip-flop on your position. Continue.
Not to mention he brings up plane waves, which don't even physically exist, so why even bring them up as if you're treating light in a way that doesn't actually operate in reality?
Complete obfuscation of the subject matter, bro.
Oh. How do you?
Well, that's why I was just slowing it down, because I want to make sure that Franco's familiar with the terms, so that way he can respond. Because if he's not interpreting the terms correctly, he may not be able to respond directly to what you guys are saying. Because the thing, Franco, we want to make sure when you're arguing your position or articulating your position, you want to make sure that it's based in sound logic. We don't want it to be fallacious, devoid of that logic. I think a good example, and I'll let you get the mic. I just want to make sure that you fully interpret the term, saying the Grinch. My claim is the Grinch stole Christmas. Right? I was expecting a gift to come in the mail for Christmas, and it didn't show up when I expected it. That must mean the Grinch exists and the Grinch stole Christmas. So I'm assuming the consequent because assuming something is happening, and because the result happened, I confirmed the assumption. And that's pretty much devoid of logic. You guys can correct me if I'm wrong, or Franco, you can respond.
You're doing good, but real quick before you respond, I was still going through my list. Okay.
I just want to make sure he's keeping up, Alan, because if you go through your list,
you're good. You're good. I know I appreciate it. Thank you.
Hey, this thing's about ready to get turbocharged, so I hope there's a lot of listeners here ready to listen.
That's a fact. Thanks, Bob. Go ahead, Franco. Did you want to just confirm that?
So Franco, let me ask you this. Okay. The classic theory and the relativistic theory both make the same prediction for the angle change, right? Yet when they go to measure it, they agree to up to 2/10 millionths of a degree.
Then we would discuss this in a minute. Okay, go ahead.
And that wasn't what was measured. So is the classic theory and relativity wrong, or is the assumption of a velocity component wrong? Because if relativity is wrong, then the classic theory would also have to be wrong because they make the same prediction. Because it's what's used today in inertial navigation systems. The floor is yours.
Okay. Can you tell me again where this prediction of two different angles come from?
Yes, the first prediction is for the angle in air, and the second is when you add water.
And how do you compute the angle in water?
You slow the velocity of light down to 0.75 c.
In which frame?
The lab frame, the frame in which the measurement is taken, the frame in which the observer exists in.
Okay. And how do you compute? Okay, so how do you compute this angle in this frame, knowing this velocity? You don't need just the velocity in order to compute the angle. The velocity of light.
The equation is tangent angle equals v over c, assuming the velocity of Earth over the speed of light. That's what gives the normal aberration angle. So why would it be different? The only thing that's changing is the velocity variable of light. So they make the same prediction. I don't understand where your contention's at right now.
My contention is that this angle of 27 whatever degrees is starting from. It's a change from a frame where the angle is 0, and then you add the Earth's velocity relativistically or classically, and then you get that the angle is 27 arcseconds. But one of the hypotheses is not just the velocity of light in the medium, is also that the angle was 0 in the frame you start from. And in this frame, which is it's not a lab frame, it is a frame where light is coming at a 0 angle. Do you agree with this?
No, give me one sec. It already comes in at an angle, right? Like we said that it's not, we established earlier that it doesn't come in perpendicular. Like the telescope is leveled at all times and it's off like inherently. So it's already coming in at an angle. That's what you guys are calling aberration to begin with.
Yeah, but the angle in the calculation of 27, let's take this. Let's take the calculation of 27 degrees.
Oh, no, I see what you're saying. As the baseline deviation from 90, I got you. Or from 0, I got you.
Yeah. Right?
Okay. Yep.
So what I claim is that this is wrong. This hypothesis that it is 0, the angle in the first place. Because in that frame, the frame where you assume the light of the angle of light to be 0 is a frame where water is moving, and in that frame, which is a frame which in videos and demonstration of the effect is the frame where the telescope is moving. In that frame, you have no way of no physical way of saying, no argument for us being sure that the
Franco,
angle is 0.
Franco, I don't mean to cut you off, but your current line of argumentation would refute aberration in air.
No.
So, yeah.
No, because your assumption in air is that light is coming, for instance, in the so-called sun's frame, is coming, for instance, vertically. At least you.
What's the cause of aberration in air?
The change of relative velocity between the telescope and the star.
What's the cause of aberration in water?
The cause of aberration in water is the same but it has to be compounded. It has to be convoluted. It has to be combined with the fact that you have an interface between water and air in this case, and that the behavior of light at the interface is governed by Maxwell's equations. And
so a different angle then, right? In the water?
Different angle in water, but this different angle is easily determined only in the frame where water is stationary. In the other case, it's not easily determined.
Wait. Let's analyze that for a second. It's only valid where the water would be stationary, right? And you're assuming that there's a velocity component there, right? And then you didn't make that measurement to the corresponding angle. And what you actually measured is the angle change as if your hypothesis was that the Earth is stationary and that the starlight comes in at an angle. So what doth we do from hither, brother?
We accept that this is a way of reasoning, and there's no reason for going back to a frame where the telescope is moving.
I agree. There's no reason to assume the telescope's moving after we have the water.
No, because this is what relativity says. You can precisely compute what happens in the frame where in the telescope's frame. In this frame, when light is coming at an angle because of evaporation in space, and that because of the relative change of velocity between the star and the frame. You can also say that it's a star moving. It's a star moving with the yearly.
Hold on, Franco. I agree that with the telescope in air, you could say that the Earth is moving with respect to the incoming starlight, or you could say that the Earth is stationary with respect to starlight that's coming in at an angle. In air, both of those are equally valid. I 100% agree with you. The problem is, though, when you add the water, right, we have that velocity component, which necessitates an angle change. Now, the fact that there's not an angle change in water doesn't mean, oh, we must assume some other way to do a transformation or come up with a reason as to why there's no angle change. It just means that the starlight already comes in at that angle. That's what the first order derivation would imply, right? That's all you have to do. You make no further assumptions. You don't have to transform into a fictitious frame. You don't have to assume any horizontal velocity components. But anyway, continue.
No, I disagree. Again, the angle change is only the only angle change that's predicted is one predicted by Snell's law in the frame where water is stationary. The other angle change that you're referring to is flawed, the calculation, because as we were going through 2 minutes ago, it assumes that the angle is zero in the frame. The calculation that predicts this 27 degrees is based on the assumption that the angle is zero in the frame of water is moving, which is not true.
It's not zero, though. It's 20 arc seconds.
No. If you
that's what aberration in air is, brother.
Yeah, okay. If you compute 27 is not using the 20 arc second. You plug in the numbers that you plug in order to get 27 is zero as theta, and then you get theta prime. It's a 27 arc second if you use the correct speed of light in water, and you use zero as the initial angle, not 20 seconds. Sorry. Try and use.
So if you do that, it's going to add 7.5 arc seconds to the 20 that's already present for air. That's the whole purpose of it.
Yeah, but the 27, my argument is that the 27 calculation is not correct because it assumes zero in the first place, which is not valid. It's not justified. It is justified in my calculations of 2 years, not 2 years ago, 2 weeks ago, was trying to see what the angle you could assume was if you use plane waves. If you use plane waves, then it's true.
Franco.
Then you have a different transformation, so it's coherent. But if you use a wave packet, it's different. But then the angle equals 0 to begin with is wrong. So in either case, whichever model you use, it's wrong. This 27 prediction is wrong.
Okay, listen. 20 arcsecond deviation also assumes the deviation from is 0. So how is that correct, but the other one's not correct, bro? That doesn't make any sense. That's completely incoherent. Zenith 0 would be the zenith of the star, right? The 20-degree arcseconds is the deviation from that already. So both equations agree already. You seem like, respectfully, seem to have a misunderstanding of what is going on right there.
Yes, there is a misunderstanding of what is going on right there because if the aberration in air assumes that in the sun's frame, the
what the fuck? Sorry, can you go ahead?
In some frame where the telescope is moving at 30 kilometers per second and the starlight is coming down vertically from zenith, then in this assumption, this is what is assumed in order to calculate.
Hold on 1 second. I need to reconnect. It's doing the echo thing. I'm sorry, I can't hear you. Give me 1 second.
Okay.
In the meantime, if I can say, what detoured us from what our own eyes see, we have to stop with this number bullshit. And we need to believe in what we see. And many of us have photos to prove.
Oh, hey, Bob, I'm back. Sorry, Franco, go ahead and continue.
So, aberration in air is calculated based on the assumption that in some frame, starlight is coming, say, along the y-axis. And then you take a telescope that is moving along the x-axis with some velocity, 30 kilometers per second, say. You compute what the angle would be with respect to the telescope using either velocity composition or wave vector transformation. Is the same in vacuum. So, and then you get the 20 arcseconds, which is the angle that light makes with respect to the telescope axis in air. When you compute the 27-degree angle, what you do is to assume that in the frame where telescope is moving and the starlight is coming along the y-axis, it will continue moving along the y-axis when it has entered water. And this is the wrong assumption, because it's from this 0 angle in this frame that you transform to the telescope and you get the 27. That is the wrong part. My calculations from 2 years, I guess I keep saying 2 years ago, from 2 weeks ago, was that if you use a plane wave model and you compute how that plane wave changes between the two frames, then the prediction is that it will stay vertical in the frame where what is moving, and then it will follow Snell's law in the other frame. If you use instead velocity addition of light pulses, then you would have to use velocity additions. But in that case, it's not true that the light pulse will continue vertically in the frame where water is moving. That is, in the first frame you start from, in order to compute the 27 angle. That is the wrong thing. The only way of knowing what happens to the pulse when it crosses the water is to go to a frame where water is stationary. In that frame, the pulse is coming at an angle of 20 arcsecond. It will be refracted in water at an angle of 15 arcseconds due to Snell's law. And then you go back to the frame where to the initial frame where light was coming vertically in air, and you find that in water it will not be vertical, and the new direction would come from transforming back the 15 arc second of the stationary frame to the previous frame. That is the way of computing that correctly in case of a light pulse. In both cases, what you need to do in order to compute what happens at the interface of a moving medium is to go to the frame where the medium is stationary, compute it there, and then go back.
Yeah. So we've done all that, and we have the prediction for the angle change. And that's not what's measured. You're assuming the horizontal velocity component, and you're saying that the laws of physics are equally valid in all these frames. So we got our prediction, we got our measurement, and now you're trying to make everything agree with the measurement and acting like it's a prediction of it. But by assuming the velocity in the first place, dude, what you just described was so hard, was really hard to follow. I'll be honest with you, it didn't make any sense. Like, that was the most what you're saying, dog, is that in air there should be no aberration then. Like, no. I don't understand how you're not realizing
I've not said that.
The contradiction there.
No, there's no contradiction.
Yeah.
No, there's no, I'm sorry.
If
If the cause is the velocity ratioed against light speed for air,
yeah,
and the cause is also the velocity ratioed against light speed for water, as you've said, but you say this prediction's only valid in the frame in which telescope is stationary, then when we take the measurement physically in the frame of the telescope, why do we get aberration in air? That's what he's asking you, because we know we get aberration in air according, to measurement. So then why wouldn't there be aberration in water? It's all in the same stationary frame that we're measuring it in. We're measuring it in a stationary frame, or we're treating it as stationary at the very least, whether you think it actually is or not. You can't have it both ways. You can't have it successfully predicting 20 and measuring 20, but then say that the prediction for 27 is not true.
The prediction from 27 is not true because it assumes what happens when light crosses the boundary between air and water. What happens to light when crossing a boundary between media is calculated imposing boundary conditions on electric and magnetic fields at the crossing boundary. And this leads to Snell's law, and this is done in a frame where the medium is stationary, because otherwise it's difficult to have a description of what happens to fields when the medium is moving. So
that's not true. That last part's not true.
Why?
Fresnel drag is measured and calculated in the lab frame in which water is moving.
How is it calculated? Fresnel? Again, Fresnel. What I'm saying is what I said. I was trying to say is that what is wrong, what is difficult to predict is the angle change when you have crossing between air and water. Fresnel's drag is something that is, or Fizeau experiment is something that happens along the wave propagation velocity. There's a velocity of medium that is parallel to the velocity of the wave, and that is accounted for by additional velocity in relativity, which at first order is equal to Fresnel's drag. So this is perfectly explained by relativity. And what I
and the classic prediction. You know, Fresnel didn't use relativity.
Yeah, he used a very complex model, which is not. I don't care what Fresnel used. I care that relativity predicts the correct things, right? So anyway, what I'm saying is wrong is not that the aberration in water is not there. What I'm saying is that the way you compute it and the way you compute the expected angle in the frame is based on a wrong calculation, because it assumes what happens. It assumes what happens when light crosses water in a frame where water is moving, which is not. Which is assumed without any physical justification. That is
well, regardless of what direction it's moving, if it's moving, right, we know from Fresnel that it should carry 44% of the velocity of the water. So what you would do then is you would take that predicted 7.5 arc seconds or so, 7 arc seconds, that predicted 7 arc seconds change. You'd say, okay, let's take 44% of that and subtract it off of it, or add it, depending on which direction we're talking, and then do it that way. But that's not what we see. We just don't see an angle change at all.
Yeah,
So you'd either have 7 or you'd have 44% of 7. You have neither of those. You just have a 0 angle change. The only thing you're not allowed to have is 0, and that's what you've got in the first order measurement in the lab. You have a 0. It would be a different angle, regardless of how different, whether you think it's different by 7 or different by 44% of 7 or whatever, it would be different. And it's not. And you, Franco, can't have that. It has to be different.
Can I add to this without? Can I kind of add to this a little bit real quick?
Hold on, Bob, is it relevant to Airy's failure?
What I have is
Bob.
groundbreaking. What I have.
No, Bob.
Bob, is it relevant to?
Slow down, people. Slow
Bob,
down.
is it relevant to Airy's failure though? Because we're in the middle of a build.
You guys go ahead and hash this out, and then I'm going to share earth-shattering proof that Flat Earth Dave knows. A lot of people know, but I'm going to let you guys hash this thing out real quick, and then when you guys call upon me, I'm going to share proof. How's that?
Thanks, Bob. Appreciate it for being patient. Go ahead, Alan. Franco, continue.
You can't have a 0, Franco.
Okay, I'm repeating the same thing over and over. Okay, but I'll do it again. So
wait. Address what I said. Don't repeat what you just said. Address what I said. I responded to what you already said. Please respond to me.
Okay, I respond to you. I don't know about Fresnel's drag and how it is used when light is at an angle. I don't want to use it because I'm using modern knowledge. And I know historically is that Fresnel's drag is a first order approximation of addition velocity, but in case where the wave or wave packet direction is the same as the velocity of is parallel to the velocity of the medium, as in Fizeau's experiment. I don't know what happens. I never learned, and I haven't looked up what it predicts in case of light at an angle, because I don't need that, because I know what Maxwell equations are and what relativity is, and I know what the prediction is now. So I'm using that, and if I'm using that
direction component.
Sorry,
I'm not trying to interrupt you. I just want to add that real quick. There's no, in the equation for Fresnel drag, there is no direction component for an angle, right? It's just plus or minus, right? The only deviation from the plus or minus would be if you had to do trig, like in order to get the effective direction. Like, say it's not moving perfectly straight, it's moving ever so slightly off from perfectly straight, but you have to calculate its magnitude in the y direction. Then you do trig, but it would still be trig of Fresnel's formula. So
again,
it still doesn't help you.
I cannot discuss this because I don't know what Fresnel predicts when light is not parallel to the light direction is not parallel to the medium's velocity.
His formula is still valid today. But what you're making a good point though, because Fresnel predicts, right, his equation, his drag equation. Fresnel drag is the only mechanism that there is by which we can add velocity components to or from light as it travels through a medium. Otherwise, light is supposed to travel unhindered, right? Fresnel drag is what occurs that causes there to be a deviation in that velocity. And it is along, or opposite to the direction of the travel of the light. Once you make it perpendicular, it would reduce to zero. It would be maximum at parallel and zero at perpendicular. And if we're treating the star as a zenith star, then it would be perpendicular. Or if it's slightly off zenith, very, 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 very small from perpendicular, almost zero. So you still wouldn't have a mechanism to add a horizontal velocity to the light. Like, you don't have any way to take that light that's coming in a straight line, because that's how it propagates, and then the moment it touches water, just shoot it off to the side at a perpendicular angle to get it to catch back up to the Earth. There's no mechanism for that, Franco. Physically speaking, there's no mechanism.
Yes, there is a mechanism, that in the fact that the way a dielectric medium reacts to electromagnetic fields is described in a frame where is described properly in a frame where the medium is stationary, and then you have all kind of models of dielectric response to that. There's a whole sector of physics about this, and then you have in order to see what happens when the medium is moving, what you do is simply use frame transformation. That is the way any modern physicist would act. Fresnel was computing things, was modeling things many years ago, before other points of view were developed. So I don't want to use that explanation, that mechanism. I'm sticking to my view of physics, and which is not mine. It's modern physics since more than 1 century. So it's the way of seeing things is relativistic, and I'm sticking to that. So in that point of view, I'll say it again. The prediction of what happens to the aberration angle in water is not that it is zero, it's not that it is unchanged, it's just that is determined, the angle that the light will form with respect to vertical in the frame where the telescope is stationary is just determined by the refraction laws, which are the way that the refracted medium interacts with light when it comes at an angle. And this angle is the 20 arcsecond angle, in Airy's case, is determined by aberration. And the fact that it changes is due to the fact that the relative velocity between Earth and the star is changing annually on a yearly period, by plus or minus 30 kilometers per second. That is the explanation of the fact that this angle changes from plus to minus 20 arcseconds in air. Again, if you try to predict what this angle is in water, the way you compute it is to see what happens to the angle change in a frame where water is stationary, and then move to any other frame. You cannot.
Hey, Sacred, can you bring Pizio back up and Proud? I think they got dropped out. Continue, Franco.
Okay, I got you.
Okay, so
I've been on standby for a while too.
so
Yeah, Bob, you're gonna have to do that, brother. It's gonna be a minute, dog. Sorry.
It's all good. It's all good. I understand. I'm listening, and I got a lot of firepower behind me. Trust me, guys. When I jump
Yep,
in, you
it'll
guys
it'll
gonna
happen
love it.
faster if you stop talking, though.
I
So
know, but you're gonna love it. I'm just
yeah.
saying.
Well, I waited with bated breath. Anyway, continue, Franco.
So I'm sorry, there's no contradiction, and then there's no prediction of in the fact that what Airy measured was 0, because what he measured was the I as I said in my posts, I did read the paper with more attention than I had before, and I found that I was indeed wrong when I assumed that Airy was tilting the telescope. In this, I have to admit that the first time I read it, I was wrong. I thought it was tilting by 20 arc seconds, so a very small tilt, in order to make the starlight perpendicular to the or parallel to the telescope axis. This is not what he did. What he did was to keep it as vertical as possible. Actually, the verticality was measured at each observation, but the deviation from vertical. And then what he measured was the angle that the starlight made with respect to the vertical. And what he measured was the angle of the starlight with respect to the axis in air, not in water, because this I found out by reading, because he corrected automatically for refraction. So what he measured was that. So that's why he didn't find any deviation from the expected aberration, which he used in the computation of the latitude. And the expected aberration is what is tabulated in his table, table, and was tabulated in the Nautical Almanac. So what he did was to measure the angle in air, and I'm sure of this because what he did was to, because of the way he describes how he calibrated his instrument, and by automatically correcting for refraction. So the fact that angle changes in water and it changes by Snell's law was automatically taken into account. And what he measured was the angle in air, and the angle in air was exactly what was predicted by the Nautical Almanac and tabulated as expected aberration, and he used that to determine the latitude, and he found that the latitude determined in 6 months apart was basically consistent with 0, the difference, apart from 1.8 arc second plus or minus 4.4, just statistical. So if you take the systematics into account, it's perfectly compatible with 0. So if it did find 0, meaning that the aberration angle was the expected one in air. So this is what he did. So my claim is not that to answer Pietro, my claim is not that the angle change is 0 in water. My claim is that the angle change in water is what is predicted by Snell's law, which is I've been saying for a long time, and this was automatically taken into account in Airy's measurement. I'm over.
Hold on, Franco. We trying to get everything situated. Probably can you grab Cole and bring Alan and Piezo up? Proud you there?
Mic check 1 2. Mic check 1 2.
All right, yeah. Can you see Alan and Piezo? Hopefully they heard the rest of Franco's reply.
You guys want me to drop down so you have room?
Yeah, I sent them a mic, but they haven't grabbed it yet. So go ahead, Proud.
I see Alan, but I don't see Piezo.
Piezo wasn't here. Yeah, we can hear you, Basil.
Oh my gosh, that was crazy. Twitter just took me off stage. Literally just took me off stage. I was still able to hear. Y'all couldn't see my mic requests. It just took me like y'all didn't drop me. It just dropped me. I was like in the
Yeah.
middle of like speaking to Franco.
I don't even know if you heard the rest of his reply.
No, I did.
Oh, you did? Okay.
I only lost like maybe like 15, 20 seconds of it or something like that because I had to close my browser and reopen it. But anyways, Franco, you rambled on through all of that to then end up saying at the end that the angle per change in water would not be zero. It would just be the angle from Snell refraction. And since Airy accounted for Snell refraction in his micrometer screw corrections before he took the angles themselves, that it was already accounted for, and therefore that's why it was zero. Or that would defeat the entire point of his entire experiment. What would be if he just automatically accounted for any angle changes or deviations in water? Then what was the point in doing an experiment to calculate the angle deviation changes in water? That isn't even touted. That isn't even suggested as to be the reason. And my question that I asked you to answer, what is the physical mechanism by which you add a horizontal velocity component to the water? The answer is not a frame transformation. A frame transformation is not a physical mechanism. It's a concept in your mind. When you transform a frame, you're just doing a mathematical calculation in your head or on a piece of paper. You're not physically uh, affecting light or photons with energy or momentum. You're not doing that by transforming a frame. I asked you what would be the physical mechanism by which you have light coming in from a star and then it touches the water and then all of a sudden it gets a 66,000 mile an hour horizontal velocity added to it so that the angle doesn't change. That was my question to you. It's extremely important that you have a physical mechanism, right? Not just I'm just going to transform it in my head horizontal velocity component to the light. The light simply comes in and at the direction mechanism, right? Not just I'm just going to transform it in my head, right? We're talking physics. There is no physical mechanism by which you add a 66,000 mile an hour horizontal velocity component. Head, my question to you. It's extremely important that you have a physical mechanism, right? Not just I'm just going to transform it in my head, right? We're talking physics. There is no physical mechanism by which you add a 66,000 mile an hour horizontal velocity component to the light. The light simply comes in and at the direction it comes in. You can't add an additional velocity vector to it arbitrarily. You would need a mechanism for that. And so that's why you have to have an angle change. And besides, on top of that, we can use an even simpler line of reasoning to prove that you would need an angle change, right? Because if you predict 20 with air, of course, you'd predict something different for water, 27 or so in this case, 27 and a half. But you could just say, okay, well, what if we changed Earth's velocity from 60,000 miles an hour to 600,000 miles an hour? Would that change the angle in water? What about 6 million miles an hour? Would that change the angle in water? What about 60 million? Would that change the angle in water? Okay, what if we change the water to oil? Would that change the angle? What if we change the oil to, some other fluid? What if, we could do all these things, and in every single case, the angle would be something different. But you know what? In 0 of these cases, would the angle change be a 0? That's what I told you in the beginning, and it's still true. And nothing that you've said has actually taken away the fact that it would have to be something other than 0. That's why I said I don't care what math you use, whether you use the standard timing formula based on the speed of light to get 7 arc seconds. I don't care if you use Fresnel drag and apply 44% to get 44% of 7 arc seconds. I don't care if you use some other formula to get a different prediction. But none of them, every single one of them, would be non-zero. They'd all be non-zero, Franco. The one thing you can't have is no angle change. But that's exactly what was measured. And that's why we told you that you're affirming the consequent, you're a priori presuming a velocity in the first place of the telescope. Because if there was a velocity of the telescope, there would have been an angle change necessarily. There is no other option other than to acknowledge that, hey, in the frame in which all these measurements are performed, where our observations are taken, where our numbers are written down, there is no velocity of our recording device, of our instrument, aka the telescope, which just so happens to be synced up with the Earth. Therefore, there's no velocity of the Earth either.
I'd really love to be able to jump in on this really quick.
Franco, respond, Piezo.
Okay. So the physical mechanism for light drag in water is the fact. Sorry, can I speak?
Yeah, double mute. Go ahead.
Okay. So the physical mechanism that you're asking for, explaining the drag in a moving medium, is the fact that the molecules of water are moving. They have a non-zero average macroscopic velocity. And when you model what happens when light hits water molecules, actually hit a macroscopic dielectric medium, is that the re-emission of light by the excited electrons in the molecules will cause a secondary electric field and a secondary wave, which then is combined with the original wave, and the net effect is that you have a propagation in static electromagnetism. You have change in the electric field, and the same happens in electrodynamics, and there's books and chapters of books written about this, and how you model this can be very complicated. But in the simplest case, you just use a dielectric constant, and you come up with a refraction index, changing effectively the velocity of light in that medium. But this same physics dictates that when light and fields cross the border between two media, then certain boundary conditions must be respected in order to respect Maxwell's law. And this is what determines the angle, for instance, of refraction. I was just to respond to a previous objection that plane waves do not exist and so on. The only way of predicting what the refraction law is to use plane waves. I don't care if they're mathematical abstractions, but you use them and you predict Snell's law using just plane waves. You know, there's approximation and whatever. But anyway, the point is that this model of what happens to a light wave when it propagates through a medium assumes that the medium is stationary on average, because it's a macroscopic averaging over a lot of molecules, and it assumes that they're stationary. Because if they're not, you have to take into account their motion when they are radiating back after oscillating under the effect of the incoming wave. And you can do that, of course, using the radiation from a moving dipole, but that is very, very complicated. And the only way of doing it, the convenient way of doing this is to move to a frame where, which is, by the way, not just a mathematical abstraction, it's a way of computing things in physics. You use the frame that you, and the coordinate frame that you deem more convenient. So the most convenient frame in this case is a frame where the medium is on average stationary and macroscopically stationary, and you compute the wave velocity, wave direction, and wave packet, whatever you want in this frame, and then you move back to a frame where the medium is moving. In doing this, you can exactly predict the drag, which is described by Fresnel's drag in to first order in beta, which is V over C. But it's not. As far as I know, Fresnel's drag is not the correct, the exact result. It's only valid to first order. Anyway, this is as far as the physical mechanism is concerned. As far as angle being zero. Angle change being zero is not zero again. It's the Snell's law in the frame where the telescope is stationary in the Earth's frame. As to your question, why, if it was corrected for automatically, which is true, I invite you to read again Airy's paper. It is true, it was corrected automatically for refraction. So why the hell do the experiment? This is precisely the point of view of a modern physicist. Why the hell do the experiment? Because in modern view, it was supposed to give exactly a zero change in aberration when aberration is computed this way. If you compute the angle with respect to the telescope axis by taking into account refraction automatically, then you would find exactly the zero result that Airy found. And by the way, I still have to understand what, because I myself asked myself the same question. Why exactly was he expecting to find something else if Klinkerfues was right? So I started to read Klinkerfues' paper, and by the way, in Klinkerfues also corrects for aberration, and he predicts, if I'm correct, that the angle would not be increased by a factor of n, but by a factor of n square. Because he explicitly said that a refraction has to be corrected for. So if you measure an angle in water, it would have to be multiplied by n in order to get the angle in air. And then if this angle is multiplied by n in the first place, then you would have to multiply it by n4 in order to get the aberration. N squared.
Wait.
N squared.
Wait, Franco. Sorry. Okay, bro. I have to say this. I'm going to reply right now, but I have to just lead with this. You ramble on like way too much. You need to be more concise for the sake of everybody listening and waiting and participating. But Klinkerfues claimed that he measured it. He claimed he measured the difference. That's why Airy did it, because he's like, oh, for real? Oh, let me do this and with an even bigger, more accurate, more robust setup and see if that's true. Because in science we like to repeat measurements to confirm them. And Airy got that fat no angle change. But you are misrepresenting what I said and asked, because I didn't ask you if he compensated for Snell refraction. I know he compensated for Snell refraction, but everyone listening to this that's kept up with it and is educated on area and understands what's happening knows that there would be two sources of angle change. One would be refraction, and the other would be the standard aberration, which is from V over C. So he automatically accounted for the refraction so that he could measure the V over C. That was the purpose of the experiment. You're conflating the two and saying that he automatically accounted for the refraction, so therefore there was no measurement of V over C. They're two different things, two different sources of angle change. The only one that we're concerned with is the V over C, because as you have acknowledged, the refraction was accounted for in his micrometer screw corrections, as we discussed on the timeline. So that being said, you say that
Yes.
the mechanism would be, the emission and re-emission of light through a medium, talking about the molecules of water and going into all that. I mean, but you're basically talking about just vanilla refractive index, right? Which, gets into molecular geometry, et cetera. But we don't need to get that nitty gritty with it, Franco. Once again, does any of that predict a zero? The answer is no. You could go do the math for any of it. None of those things would predict an angle change of zero. It is absolutely preposterous. There is not a single framework in all of physics in which you introduce a new medium for light in which the velocity is slowed down and then the angle would not change on the aberration that was already there. It would have to change. It has to change.
If I didn't care so much, you guys, I wouldn't keep trying to jump in, but
Hey, y'all need to watch out for Bob. He's been going in these spaces. He just like real racist guy. Just wants to talk about
whatever,
Trump.
whatever. You're
Man,
lying.
yeah,
Nah,
Bob's
he
a real
just
Piezo, Alan, Franco, forgive me. Bob, I'm gonna let you chime in here because you won't stop interrupting, and then we're gonna continue on. I'm sorry, Piezo. Sorry, Franco. Just give us 1 second. Bob, please make this good because you have not respected anybody's voices here. Although you have demonstrated patience, but hopefully you have something of value to add as we're conducting a dialogue with a PhD physicist. Please make this good, Bob. Do not disappoint my audience.
Well, I appreciate that. Honestly, I appreciate that. There are, man, wow. My mind is blown. I'm not in here to invade anybody's spaces. I'm only here to shed the light on the
All
truth.
good, Bob. All good. All good. Let's get to it because we
nah.
got stuff
Bob,
All
we
right,
gotta
all
handle.
right. Hey,
Bob,
Hold on,
should hop
Tyrone.
in
I got this, bro. I got this, bro. Please don't interrupt. Thank you. Bob, please continue. Unmute your mic and get straight to the point.
all right. Well, I shared some photos in the box there to prove some of my credibility. But man, if I'm going to be treated like I'm a shill or whatever, that's not going to work, man. I shared, these are my original screenshots and videos, and I have lots more to share. And they are all from this very phone I'm talking to you guys with. So I don't appreciate whoever was trying to discredit me. I have lots of people who have really admired
Hey,
my work.
Bob. No, please don't focus on that. We're here
Well,
for the information that you want to share.
yeah.
Please, I'm asking. I'm really trying not to censor you, and I don't want to remove you. I'm giving you the opportunity to give us the valuable information that you want to share. Please focus on that.
All right. What information do you need, and I'll give it to you.
Whatever
Yeah,
you've
shut
been
the fuck
trying
up.
whatever you've been trying to interrupt and share, you have another 30 seconds to get to it. If you don't have anything to share, we're gonna move on.
All
But we
right.
really want to hear it, so please proceed directly.
All right. Well, it's funny when it comes to my turn to talk, I get, spoken to.
Bob, it's not even your turn to talk. We're being
Yo, Alan, chill, bro. Chill. I got this. Bob, Continue. Do not acknowledge anything else other than the content, information, whatever value. This is the third time I'm asking you to please respond to it directly.
It's kind of hard when I
Just open your mic and tell us about these images. I'm on your page right now. I'm in your replies. It looks interesting. Please break it down to us concisely and directly. Go ahead.
All right, you see General Flynn's following me, and you see that lots of big people are following
See,
me.
this is what I'm saying, Bob. He likes to go in these
Dude,
spaces.
you got
Yo, okay. If anybody interrupts Bob, I'm taking your mic. Anybody. I need to get through this. Do not prolong this. I want to get back to talking to the PhD physicist. That is the last time I'm going to say it. Really trying to be kind. Really trying to make sure that everybody gets their voice heard. I really do appreciate everyone's patience. This conversation has been ongoing for weeks. We're finally getting to a little bit of some type of understanding. And with the interruptions, we're never going to get there to a solution. We're going to keep on having a circular argument. So if you don't have any patience, I'm going to allow you to go now, Bob. Please tell us about what you have to offer, what you have to share. I'm on your page. I'm in your replies. Do not interrupt Bob. Bob, you have the floor. You have 30 seconds to get to the point. But if it's something valuable, you can continue.
well. I appreciate that. I'm not here to waste anybody's time, and my time is valuable too. All right, all of our time is valuable. And I'm really tired of these knuckleheads coming in and trying to silence my.
You got another 15 seconds, Bob, to get to the actual point. Please do not acknowledge anybody else. You are validating what they're saying about you. I'm the host. I'm talking to you. I would like to personally know what you have to offer. Do not talk about anything else other than the content that you have to offer the space. If you don't have anything, then that means you're going to relinquish your mic and relinquish your time. That is the final time I'm going to say it. Please, Bob, share with me what you have to offer. I think this is like the fourth or fifth time I'm asking. Please, just focus on what you want to share to the space. We are all paying attention. This is your opportunity. Please respond. Please open your mic. Focus on the content, please, bro.
Well, my mic's been open the whole time, but I keep getting shut off. I shared plenty of photos in the thing. I've been doing this for a long time. I've been on a lot of spaces. I've been censored to hell for years. I have plenty of evidence and proof that the moon is way closer than what we've been taught. Okay, so but when you guys come in and try and rush me to talk, and you let everybody else come and freely talk before me, it really raises an eyebrow to me. You know what I'm saying? It's really not right. I don't, man. Don't rush me. You didn't rush anybody else to speak. This
Yeah,
is
but
the
no one else interrupted but you.
dude. You
So
are
no
cutting
one
me
no
off.
one else
No,
interrupted but you.
all right.
Everyone has been having their hands up.
Because they've been speaking
You have literally
on about nothing. I have lots of.
okay. So you could listen, bro. I'm really trying to be patient with you, Bob. This is your final chance. If you do not tell us about the value, that means you are here to waste time. I don't believe that. I think that you're easily sidetracked. I think your attention span is a little bit short, and that's okay. This is why I've been patient. I do not want you to respond to anybody else. I don't care about your history with anybody else in the space. The only thing that I am focused on is your evidence of a local moon. Super interesting. I've said this is your final chance 3 times. I just want you to respond
I heard you a million times.
and please do what I'm asking.
6 years old, dude. I have the best proof in the world that the moon is local. The best proof. Okay, I don't want to be talked to like I'm a little child. I'm 56 years old. I have the best proof of the planet, and everybody knows it.
Then tell us, Bob.
Cut me off like a little child.
We're waiting.
I got it. I'll share more and more and more, but I'm not going to be fucking scolded before I talk. Okay? So
We're waiting, Bob.
I got the proof. If I can film the moon with my iPhone and film entities on the moon with my iPhone, that tells me the moon is a hell of a lot closer than what we've been taught. And I have tons and tons of videos and screenshots to prove it. And I have tons of videos
and screenshots of entities entering portals in mountains along Essetti Ranch and in Washington State, all over the place. And I will not have anybody fucking scold me on how to fucking talk. That's bullshit. Even to the fucking host, I'll say it to your fucking face. Don't talk to me like that or anybody. You're gonna fuck up. You're gonna lose people who have solid proof.
Bob, we're waiting.
I wouldn't have the followers I have. You said you've been on my page. I wouldn't have the followers I have if I was full of shit.
Man, sorry, host. I just want to say this Bob
Don't
guy.
cut in on me.
This
He said
Bob
don't
guy
cut in.
just likes to talk about himself, man.
No, I
That's why I
my
came up
photos.
here to warn you about this guy.
Yeah,
He goes into these
My photos,
spaces.
my photos.
He create.
Oh my God.
At this point, I'm feeling intermission.
No, I want to get back to the sauce, bro. I'm tired of the circular arguments between Franco and Alan and Piezo and Airy. Like, I want to get to it. I want Franco to understand the position. I want them to be able to articulate our position. I want Franco to correct anything that we're wrong about. We can't get there because people want to interrupt. They don't have no patience. It's frustrating. I'm literally trying my hardest to get Bob to answer the questions. Does anybody see me not trying to get him to get to the point? I think it's very clear.
Yeah, great. Way more patient than I would have been there, Sacred.
Yeah, I mean, I even said, like, don't interrupt him because, he's just going to deflect. And it's like, y'all, like, want me to take y'all mics. And that's, like, making me cringe so
no,
much,
man,
bro.
I was just trying to warn you
That's bullshit. You guys
about
are
this
fucking
Bob
lying.
guy.
Oh
He
my
likes to talk about
God,
himself.
bro.
All he does is talk about himself, man. I'm
All
trying
right, bro,
to warn you about this guy.
he's gone. We heard you.
Thanks, dog. Thanks, dog. I'm just looking out for you, brother. That's all.
Appreciate it. Is Alan still here? Is Piezo still here?
Yeah, so the whole point before that ultimate derail was that, and no offense to you, that's all him, but thanks for, you're just a nice guy, Sacred. You're just a nice guy. You're just trying to have a good space. I get it.
Yeah, and I will post his pics up top, and if he has a little bit more patience and self-control, he can come jump back up later. Y'all can go look at some of his images. It looks super interesting. He just doesn't want to explain it. So I'll post it up top so that way, y'all can at least get that information that he didn't know how to articulate. But continue, Piezo, and we'll try to get Alan back up here.
Yeah, but the recap, just everybody to bring us all back in. Here's the TLDR, the overview, the summary, the recap of how this all went down. Franco and Hapro were on here arguing with me and Alan like 3-4 weeks ago about this particular topic, Airy. We were asking them how is it possible that there was no angle change. They said that they would apply a coordinate system transform and translate the velocity of the Earth onto the light incoming, so that it would move at the same speed horizontally and travel with the water, so that there would be no angle change. That's what they did. They did a relativistic velocity addition, equivalent to classical. They did a velocity addition, and then when we argued with Franco for weeks on the timeline, finally got him to acknowledge the math itself predicts a change from 20 to 27 arc seconds. He said that he acknowledged it, but that you could not apply that equation because you can't do velocity addition for light waves. Because once it touches the water, it's no longer a particle, it's a wave. You can't do it for light waves. And then we got him in here and called him out and said that that's absurd. How can you say that you can't do velocity addition for light waves when that's literally the entire basis of interferometry itself, a la Fresnel, MMX, Michelson, Gale, Pearson, Sagnac, et al., ring laser gyros, inertial navigation systems, everything. And he said, well, if it's a plane wave, and he said, but is starlight actually a plane wave? Well, no. Okay, then why bring it up? Okay, so that means that, these equations are valid. So why is there no angle change? And then the last thing that we were on was he was talking about how light is absorbed and re-emitted through the molecules in water, which is just the actual nitty-gritty explanation of a refractive index of a medium in general. That's just vanilla in value, right? And it always would involve a velocity component, which would be non-zero. So the question that still remains, that is unanswered, and will forever remain unanswered because there is no answer, is how can it possibly be that Airy measured the standard aberration angle in air And then when he added water to the telescope, it remained the same angle when it should have changed by, 7 arc seconds.
I think he said refraction.
Yo, before you continue, can you hear me? Mic check.
Yep.
Okay, thank you. Yo, my bad, Sacred.
We can't hear you now, Alan.
I muted. Is Franco there?
I think so.
Yeah. Yes.
Did you hear that, Franco?
Yes, I heard that, and I still stand by my position, which is that
still copping that zero. The zero change.
No, it's not zero change. The change is the one predicted by Snell's law, by refraction. It's not the 27 degree
separate.
Is
separate calculation, brother dog.
Yeah, it's
the
a separate
aberration
mechanism.
calculation.
There's two mechanisms, Franco. We
Yeah.
already covered this. One is the refraction, and the other is V over C difference. You're conflating the two and making them one. They're separate.
Yeah, they're separate.
Otherwise, there'd be no. Otherwise, there would not be a point in doing the experiment. Airy was not a retard. He would have known that. He did know that.
Didn't know relativity. So in relativity,
need to know relativity to know that there's two different sources of angle change.
Yeah, but if you can compute the expected angle change correctly, and if you if you do it correctly, it is not 27 degrees. 27.
Not a zero.
It is not zero. It is. It goes
okay,
from.
Thank you. But they measured zero.
No, they measured 15. They measured 15.
They measured zero change. Zero change.
Negative white power.
Change because what he measured was 20 arc second, which is the angle in air, which is corresponding to 15 arc seconds in water. That is what he measured. No point in doing the experiment because from the modern point of view, there's no point in doing the experiment because the modern prediction.
There's definitely a point in doing it. The modern prediction's not zero. I gotta go. This has been too long. Thank you for your time, Alan. I'll leave it to you, bro.
Yeah, same as 2 weeks ago.
Yeah. Well, I think with that said, we reached no middle ground other than it's just obfuscation. There's no way to account for the angle change difference. No matter what you try to make it about, you can't have it. Otherwise, you either contradict it in air or you contradict it via asymmetrical use of Lorentz transformation. So anyway, and like Pizio said, there's actually zero theories that predict a zero angle change. So anyway, that's what I'm going to close on. But one final thought, though. No, it actually doesn't even fucking matter. We're good. We're all squared away, Franco. Thanks for coming out and talking this out, man. Much appreciated.
I still don't agree, but and I'm not the only one, fortunately. But okay.
I'm just asking, Franco, what with the modern
I lost audio. Give me 1 second.
With the modern calculations and predictions, what would they predict an angle change to be, like including general relativity and stuff, and refraction or whatever? What do you think the angle change? What would modern science predict the angle change would be?
That's my whole point from the beginning. The modern view would be that the only change in the telescope would be due to refraction, and that was observed.
What would that angle be?
Was using a wrong prediction, and he was trying to see whether that wrong prediction was right, and it was wrong indeed. And as was commented,
what was wrong? What was wrong about it?
Sorry?
What was wrong about it? Calculations match relativity. What was wrong about the prediction?
Oh,
The
they don't.
prediction's fine. It's the measurement disagree with the prediction, bro, not vice versa. But anyway, you guys have a good night. My audio keeps tripping out. And Sacred, I don't know if you heard me earlier, but I apologize for interrupting during that, dude. I got a little carried away there, dude.
Nah, it's all good, bro. It's all good. It's all good. I in my